Go. Okay, so Unit 2, we're going to learn about mass of subatomic particles. We're going to learn about isotopes today, nuclear notation, hyphen notation, and calculating average atomic mass for an element. So, we're going to be using our periodic table. So if you got your periodic tables, get them out. I'm going to have you watch a little video here, but get us started.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times,
magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, then argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and
periodic
manganese.
table out,
This is the
open up your
periodic
periodic
table,
table.
noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells where electrons are added, moving to the right. Iron is the 26th, and cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium, and indium.
Sorry, I'm going to increase the volume just a little bit.
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits.
So sort of follow
where
on with your
lanthanides
periodic
have
table.
just begun. Lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead that is knit for your tummy,
polonium,
astatine would not be yummy,
radon,
francium will last a little time,
radium,
then actinize at 89. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells where electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, indolium, nobelium, lawrencium, rutherfordium, wm, spermium, borium, hesium, meitnerium, obsidium, mercurium, copernicium, natrium, flerovium, pentium, livermorium, septium, noctium, and then we're done.
Hey, you probably wondered why I made you see that again, right? We're actually going to be using a lot of the stuff on here. I'm not going to have you memorize the periodic table. You'll actually be able to know where things are by the end of the year. You'll have basically memorized it yourself, because there's a lot of elements that we use a lot. We're going to be using what's called the atomic mass unit. Can anybody remember from our last unit what that was? What's atomic mass unit? Instead of grams, really grams of each element, what do we use? Yes?
Like gravity?
Not gravity. Good guess. Okay, atomic mass unit right here, or AMU, is 1/12 of a carbon. So the mass of a carbon. Now, remember that we're going to compare everything to, like, our protons, neutrons, electrons. They're so small to weigh. Remember, they're 10 to the minus 24 and 10 to the minus 28. Yep. I don't know what's on your shop. Yep. They're so small that we give them a relative mass of 1 and 2, or 1 and for the neutrons and 1 for the protons. So when we talk about carbon, that's the relative mass compared. Okay? So going forward here. Oh, go back. Okay, the atomic mass unit, or AMU, is 1/12 of the mass of the most common isotope of carbon. So 1/12 of the mass of the most common isotope of carbon. Got it? Yes?
What's an isotope?
So we're going to go into. Not yet, but it will. Okay? Good questions. All right, so this is just a reminder, and you've got another chart, so if you've forgotten this from last unit, you can put this down really fast. Remember a proton, we use p with a lowercase p with a positive, and its charge of +1. Its actual mass is 1.67 times 10 to the minus 24th. That's the same as a neutron. Remember, they were off after that a little bit, but the first three were significant. Remember, an electron was a negative charge, and I helped you remember that because an electron is negative, and because it's a negative experience to dial 911, okay, because you need help, something bad's happened. The relative mass is 1 for protons and neutrons, and 0 for an electron, because it's so far off that just 3 significant figures, it rounds to 0. Okay, relative charge we got there, where they're found. Protons are found in the nucleus, neutrons are found in the nucleus, and electrons outside of the nucleus. So we should be able to get this. And I'm going to put this recording up on your daily work so you can go back over it again if you need to. In case you missed any of, okay? Yeah, they're a little mixed up. No, they're the same place. Proton, on your chart. On your chart, sorry. Yeah, that makes you think. Make sure you're thinking as you're writing down. It's not the exact same as the chart up here. Okay, so you guys have proton first, and then electron, and then neutron. So these two bottom ones on each of the chart are switched. Nice to point that out because I see a lot of erasing going on. Oh my God. And that would be physics. It's fun. Okay, we got it all figured out now? Hold up. Actual mass is right here. The relative mass is what we'll be using, and you can put that off to the side. It's like a 1, 0, 1. That's off to the right side of that on your chart. Okay, also remember that proton we write as P plus, neutron we write as a lowercase n with a 0, and electron we write with a lowercase e and a negative. We'll be using that a lot in this unit, so if you don't have it down, write it down somewhere next to that. Okay, so make sure you write the shortcut down because you'll want to be able to do that instead of have to write that out, because a lot of times when we are using proton, electron, and neutron, we have little itty-bitty space to use it. Okay? We good to go? All right, we're going forward. All right, so carbon's mass, we've got 99% of it that is just 12. Remember I told you that the masses on the periodic table are an average of all the different kinds of that element? Well, the different kinds of the element here are carbon-12 and carbon-13. These are known as isotopes. An isotope has the same number of protons but different number of neutrons. Okay, the proton is the identifier. The proton tells me what element I have. But I can have different number of neutrons because neutrons are neutral and they don't affect anything. Okay, so this one has one more neutron. Carbon-13 has one more neutron than carbon-12. We would times it, the mass number by the percent to get our atomic weight, which is up on the board. Okay, and we're going to be doing some of those in just a minute. Remember that this right here is an average mass. It's not the mass of a single molybdenum or carbon atom. It is the average of all the isotopes because we don't know what we've got as far as isotopes. Okay? So mass number. What is a mass number? Mass number is the number of neutrons plus the number of protons. That gives me a mass number. It is a whole number. Okay, so mass number is a whole number. Yes? So average atomic mass is the weighted average of all the different isotopes. So we're going to use the percent and the mass like we just did on that last slide. So for mass number, this is what's called a nuclear notation up here that they've got. The top number is the mass number. The bottom number is the atomic number. So the top number is the protons plus the neutrons. The bottom number is just the protons. And then we would put the symbol. Okay? So this isotopic symbol is known as the nuclear notation. So this is nuclear notation for cobalt-59. So this is a chart that you have on yours, and this goes back to carbon again like we had on the other chart. Okay, so carbon has about 98.89%, that is carbon-12, and about a little less than 1.11%, that is carbon-13, and a little even more, I don't know why that's not there. Okay, whoops, let's try going back. Okay, we're having fun here. A little bit more, that is carbon-14. Now, carbon-14 we use to date things. Okay, so that far one that has that on there, that's just where I got this diagram is showing. So the mass number is the protons plus the neutrons. And you'll notice the protons all the way across are the same because that identifies it as a carbon. The neutrons can change. Okay, just remember that. In an isotope, protons stay the same, neutrons change. Not electrons, but neutrons. So we've got two different kinds of ways that we can report. This one is called hyphen notation, where you just give the name of whatever element you have and you put the mass number. So this is all under isotopes right here that you're working with. Yeah, underneath isotopes, there's two different ways we can report it. This is hyphen notation. On hyphen notation, you're writing the name, dash, and the mass number. So we're right here. So right under isotope, this is what you're putting. Hyphen notation is the name, dash, and the mass number. Okay, the other way that we can write isotopes was our nuclear notation. On the nuclear notation, you're going to have the mass number over the atomic number with the symbol of the name. So if you want to write that really quick so you know the difference, when I'm asking you write it in hyphen notation, write it in nuclear notation because we use them for different things. Mass number is the proton plus the neutrons. Mass number is protons plus neutrons. I'm going to bring up one more program while you guys are writing that real quick. Okay, everybody got that down? So you need to be able to write me both hyphen and nuclear notation. So we're going to be practicing. Okay, that's the next page is the practicing. So, we okay to go forward? All right. So, here we have carbon 14 and iron 58. Okay? So, the mass number, it tells me that right here. So, the mass number is 14. In order to find the atomic number, all I have to do is look at my periodic table. So look at your periodic table. What number is carbon? 6. So it has 6 as the atomic number. The atomic number also tells me the number of protons. So I'm going to put 6. Now, as long as it's a neutral atom, meaning it doesn't have any charge, protons which are positive and electrons which are negative have to be the same. It didn't give me a charge. So the electrons are 6. They're the same. Neutrons, we're going to take 14 minus 6. So 14 minus 6 is what? Because that's what number carbon is on the periodic table. Okay, so good. And those of you that subtracted that and told me 8 from the neutrons, great. So now we need to write the nuclear notation. So what is the symbol for carbon? C. So we're going to put a C here. What was the mass number? 14. So it's going to go on top. What was the atomic number? 6. It's going to go on the bottom. And we've done our nuclear notation. Okay? I want you to try iron really quickly. I'm going to give you a few minutes to get a head start on me. And then I'll put it up and let's see how you did. Iron is in the middle section. Almost perfectly in the middle. That's the number on the periodic table. If it didn't give you a charge, when they gave you the hyphen notation, it doesn't have a charge. Yes? As long as there's no charge. We'll do some here where there's a charge, where the protons and electrons are not the same. Then it has a positive or negative charge. They'll tell you. And we'll do some there like that in just a sec. So don't look up until you're ready. Okay, thumbs up, I got it. Thumbs down, I didn't. Thumbs sideways, I got partway through but gave up. I only see like 5 thumbs, guys. Come on. Okay, let's go ahead and go forward. Let's see what you can do with chlorine and phosphorus. Again, I'm going to give you a head start, and then I'll put it up on the board. So go ahead and do the next ones. Instructions to this will be up online too. Okay. Okay, let's see how we did. Thumbs up, I got them. Thumbs down, I didn't. Thumbs sideways, I got one of them, or part of it. Some of you are just non-committive. Okay, if you're thumbs sideways or thumbs down, if you're having a hard time with this, when I have some rotation time, please bring me in. We're going to go ahead and go forward here. Now we're given the nuclear symbol. Sometimes the nuclear symbol does not give you the atomic number. Why would they not give me the atomic number? Because they didn't feel like it. I can always find it. It's always on the periodic table for every element. It's the same for that element. Okay? So I could really quickly put the rest of this symbol up here, which would be what? What is it for carbon? 6. So I could have put the 6 here. But since everybody knows that's 6, a lot of times they drop that out. Okay? But I want you to complete that if it's in a chart. So let's look at uranium. What would it be? It's on the bottom. Good. And lead, it's in the far right. 82. Okay. All right, so really quickly, this time you're going to give me the hyphen notation down at the bottom. So you're giving me the same kind of things, but the bottom is going to be a hyphen notation. Remember, that is just the name of it and dash the mass number. Okay. I'm going to wander around. If you need help, please stay up with us so you get what we were doing. Okay, I'm going to use you guys because I don't have a calculator up here. What did you get for the number of neutrons for uranium? Good. Okay, what did you get for lead? Okay, was this hard? Okay, it should be about the same thing. The only thing we did was we took apart what we would have made last time, which was the nuclear notation, and made the hyphen notation. Okay, so going forward, this is your practice. So what I'm going to do now is I'm going to bring up, and we're going to make the atomic snowflake together, and your practice is what you're going to do in your rotation. So if you would get, where did it go? I guess I minimized it and didn't like to go there anymore. There we go. Okay, so I'm going to project what I'm doing. You got to stay up with me with the snowflake or you're going to get behind and not know what to do. So grab your snowflake and we're going to fold our snowflake before we cut it out. So if you didn't pick up a snowflake, it's right where we logged in. Go grab one real fast. Okay, first fold is going to be right along this line. You're going to fold it so it goes like that. Okay, so you're going to fold it so it goes like that. Okay, everybody there? When you're there, hold it up so I know you're there. Awesome. Just waiting for a few more. Okay, so you want it so it's flat. Okay, see it's flat, square. So if you fold it on the other one, you don't want that one. You want the flat, the square one, the one that makes it more of a rectangle. Okay. Our second fold is going to be on this other line here. So now we're going to fold it behind so we still see the picture. So we're going to fold it behind. Really quickly grab a snowflake and join us real fast. And you'll want crayons and the packet too. Okay, got it? You should look like this. Okay, should look like this. When you get that far, hold it up so I know you're there. So again, it should be, I don't know, like this. I'm going to zoom out just a little bit more. Okay, or that way, whichever way you want to look at it. Okay, got it? Okay, everybody hold it up so I can see that you got it right. Good. Okay, now we're going to take this part right here. So this part right here, we're going to fold it back behind. We're going to fold it back behind so we end up like this. Mine's not real perfect here, so I'm going to try and make it as best you can, make it perfect so it sort of touches on both sides. Because when you cut, you need to make it sure it goes through. So once you've got that, I want you to hold it up. So you're going to take this part and fold it behind. This part, fold it behind. Okay? All right, at this point, you're going to have to share scissors. So grab a pair of scissors. I think there's one, maybe two on each thing. So you're going to take and cut this outer part off. So go ahead and cut that outer part off. What we're doing right now is we're making a model of Bohr's snowflake atom. So we're going to make an isotope. So I'm just cutting this part off. Nope, we just need this bottom part. So we're just going to cut that top part off. Thank you, Adam, for putting out your name tag. Okay, everybody got that cut off? Okay, now, next comes cutting this section out right here and this section. So you're just going to come from the side and you're going to cut this section out right here. Like that. So you get this on both sides. So you're going to have, looks like an ant with antennae. Okay, so now I got my little ant with antennae. So you're going to cut out this part right here, that was right here, and this part that was right here. Both sides, yep. Okay, when you get your little ant with antennae, hold it up so I know that we're ready to move on. Okay, we're going to be handing these in today, so you need to make sure you're staying up with me. Okay, now comes the tricky part. In order to get these parts, all this black part cut out, you're going to have to end up folding this in half at different places. So here I can cut this one out, then I'll have to refold it if I've got this one and get these little triangles out. So you're just going to fold it to get a triangle and cut the triangle out here. So just fold it in half so the triangle, you're in the middle of the triangle so I can cut it out. Okay? So I've got a couple that I can do right on that middle line. You might have a little bit different snowflake. There's a couple of them out there, different ones. But you want to cut all your little black things out, all your little black triangles out. So you're going to fold it right on the triangle. So I've got a second set of triangles right here. So I'm going to fold it right on the peak of the triangle and cut those just a little. Be really careful not to cut all the way through the edge there. But cut those little triangles out. Like this. So right here, so you take and wherever it is right there, where the peak of the triangle is, you fold it right there and just cut a triangle. So I've cut a triangle right here. So I'd have to cut it out. So when I'm done, I've got all these little triangles cut out. They might not be perfect, but they're all cut out. Okay? And this is a skills test. So fold it to get a little triangle so you can cut in and do a little triangle cut. And then fold it on another one to get the other one. Fold it on another one to get the others. Does that make sense? Okay, so I wanted to get this triangle, but I don't want to poke the scissors in. So you just fold it in half right here so that you can cut one cut here, one cut here. And it makes a triangle. Okay, when you do that and get it all done, you can open it up and you've got a lovely Bohr's snowflake. Okay, it should open up and be something like this. Yours might be a little bit different. It's okay. And it's okay if some of these got cut because some of these things are off. Okay, just go ahead and open up your snowflake and hold it up so I know that you're done and we're ready to move on to the next part. Because we're only going to do some of it together. The rest you're going to color and do on your own. Okay, so the easiest way to do the parts right here is just fold it right like this. And you just take your scissors. If I can get my thumb in there. And you go here and there. And so you just cut off a little corner. Okay? Your scissors don't work. Trade. Okay, we getting there? You have a lot? I had a lot too. Okay, almost there? No. So if you're watching the video, you might want to go forward if you got your snowflake made. I'm recording. You're looking at me really weird. Rather than just sit here and watch me. I can't pause this kind of recording, so. Okay, we ready? No, still no, no. Okay, those of you that are ready, go ahead and get out a black or blue pen. Black or blue pen. You'll want to use a pen because you're going to be writing inside these little circles. So pen, or you can actually use a pencil if you want to, or use the black pencil from the colored pencils. Okay, something that's going to be dark. So if you've got the colored pencils in front of you, you can use one of those that's black or dark. Okay, so here we go. We ready? You got your black or blue pen or pencil? And you've opened it up, I hope. Okay, you see these little blobs on the outside? Okay, see these little blobs on the outside, on the circles? You're actually going to make them a circle, and within that you're going to put E minus. They're going to represent our electrons. So go and do that on both sides of the snowflake. You're going to do circle, E minus. They're just some of them will look like they're just barely a bump. Make them into a circle with an E minus.
Are there 3 or are there 6?
Different snowflakes have different amounts. So mine has a lot. Some of them only have a couple. So depending on which one you got. So put a circle around these extra circle out here. Put E minus. E minus. I did this one on purpose because I've got a lot of them. So those of you that are slow and trying to catch up, you can do that. Flip it over, do the other side. E minus. E minus. E minus. E minus. Remember, electron is a lowercase e, so make sure you're using a lowercase e. Okay, so count how many E's that you have on your outer ring on one side. How many E minus you should have got? So I'm going to count mine. 1, 2, 3, 4, 5, 6, 7, 8, 9. You should have some kind of bump or some kind of out jet.
Got like on the ends of these like points.
So this is one, this is one, right there.
That's
You've
it.
got 2, yep.
I like
Yep. Oh, wow. Okay, when I'm done, I'll really quickly make you another one real fast. It's okay, that's okay. All right, so you're doing that really quickly. I'm going to zoom in here a little bit because it's sort of hard to see from far away. Okay, so you've counted how many E's you've got on your outside circle, yes? Okay, however many E's you have on an outside circle, you're going to use these inside are going to be circles, and you're going to put P pluses because we're going to have a neutral atom. So however many E minuses you have on the outside, put P pluses in the center. And it doesn't matter where you put them, just as long as they're in the center. Notice that these make circles, though. Don't make little circles inside of them. Use the circle that was made with your snowflake to make those circles. So I had 9, so I'm going to put 9. 1, 2, 3, 4, 5. Just random, wherever you want to do it. And then do it on the other side, that same amount. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just round about in there somewhere. So I do that on that side, and I do it on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, everybody got that done? Now, see all these other extra circles? Those are our neutrons. So we're going to do N zeros on the others. So we're going to do N zeros. However many are left that are not your protons. So the rest are neutrons. And you're going to do that on both sides. Whatever's left on both sides. So every one of those circles has something in it, either a P or an N. The P's should match the number of electrons on the outside. The N's don't matter how many you've got. They just fill in the space. the N0, N0, and superscript 0, I should say. Okay, once you got all that done, put your name on one of these, coming on around the outside. And we're going to put the isotopic nuclear symbol and the hyphen